Electricity is so much a part of our daily lives, we don't even think about it. We take it for granted that when we flip a switch, a light will come on. Or that when we adjust the thermostat, the air conditioning will blow cool air in the building. Yet, many of us don't understand what electricity is or how it actually works. Understanding electricity is crucial to installing, maintaining, and repairing HVAC equipment, and most importantly, staying safe when working around electrical equipment. That's why we're going to take a closer look at electricity today. But to understand electricity, we're going to need to explore the science of tiny invisible particles and how they behave. Basically, electricity is a flow of charged particles called electrons. Every electron has a negative charge. The negatively charged electrons repel each other. They want to get away from each other, which is why they move. It's just like how the south pole of magnets repel each other. The movement caused by the electrons repelling each other is what causes electricity to flow. And understanding how it flows may be the most important thing you learn today. Electricity always follows the path of least resistance. We're going to say that one more time because you really need to remember it. Electricity always follows the path of least resistance. Materials that create less resistance, like metal and water, allow electricity to move more easily through them. So they are called conductors. Materials that create more resistance, like rubber, plastic, vinyl, or glass, and do not allow electricity to flow easily, are called insulators. Using conductors and insulators, we provide a path of least resistance for the flow of electricity to follow. With this power cord, we have created a path of least resistance along the metal wire inside and surrounded it by plastic on the outside to keep the electricity on that path. Let's take a closer look at what it takes to get electricity flowing along electrical wires so it can power things like this air conditioning unit. To get electricity to flow, you need a closed path or closed circuit. In the simplest circuit, a power source provides electricity, which travels along a wire and back to the power source. If there's a break anywhere in the path, you have an open circuit and the electricity stops flowing. Add a light bulb or a motor, and the electricity will flow through it and provide the power needed to make it work. Add a switch, and you can stop and start the flow of electricity. Any electrical circuit can be represented on a wiring diagram or schematic. On the diagram, the power source is represented as the power device, our light becomes a load device, and our light switch is a switching device. This is a very simple circuit, but the electrical circuits used in heating and air conditioning can get pretty complex. Being able to read, understand, and implement these diagrams are one of the key skills required of HVAC technicians. Knowing how and where to measure the flow of electricity is another big part of an HVAC technician's job. You can't fix it if you don't know where the circuit is broken. We've all heard of volts and amps, but what are they? And what do they measure? Technically, voltage is the difference in electrical potential across 2 points, but it's also called electric pressure. Let's think of voltage as being like pressure. We're all familiar with the air pressure in tires. The more air you put in a tire, the higher the air pressure is inside the tire. With electricity, the more charged particles you pack into a battery, the more they are all trying to get away from each other, and the higher the voltage in the battery. We measure voltage in volts. Electrical current is something else we can measure. Current refers to how fast the electricity is moving. We measure current in amps. The more amps, the faster the current, and the more electricity. You can think of amps as being the amount of electricity. HVAC technicians use meters to measure the voltage and current in electrical circuits to determine where and at what level electricity is flowing. That helps them track down the source of electrical problems in HVAC systems. To complete our lesson on electricity basics, we need to talk about the two different kinds of current, AC and DC. DC stands for direct current, which is current that moves in one direction from one place to another. Pretty simple, right? DC is used primarily in low voltage applications. One of the most common examples is in battery-powered devices. AC stands for alternating current. It is a current where the direction rapidly switches back and forth, but energy is still transmitted. That's a bit more complicated than DC. It's kind of like the way energy is transmitted through a spring. The energy moves along the spring, even though the individual coils simply move back and forth. AC is used for high voltage applications because AC has the advantage of being easier to transform from high voltage to low voltage. That's why it's used in power lines. High voltage electricity flows from the power plant through the high voltage lines, then steps down to a lower voltage with the help of a transformer, before entering our homes and businesses at a safe level for us to use. Electricity powers air conditioners and heat pumps. Even gas furnaces need electricity to power the thermostat, the fan, and switches in the furnace. And that brings us to the most important thing you need to remember about electricity: safety. If you come into direct contact with electricity, it's going to hurt a lot at best, and it can kill you at worst. So our goal is to avoid direct contact with it at all costs. And that brings us back to one of the things we learned at the very beginning. Electricity always follows the path of least resistance. Most of the time, electricity stays where it's supposed to, inside the wires and devices of the carefully constructed circuits we've created for it. But if the circuit is not set up properly, or if the insulation covering a wire wears away, electricity can find a new path of least resistance, which is called a short circuit. One path you don't want it to take is through you. Your body is mostly water, and water is a good conductor, so you make an excellent path of least resistance. Don't be the path of least resistance. Always follow proper safety precautions around electricity. If you understand electricity, you don't need to fear it, but you should always respect it. That means wearing proper equipment and following proper safety procedures when working with and around any electrical device or apparatus. Taking these precautions can prevent you and others from being injured or worse. Working with electricity is serious business. That's why it's important to understand how electrons are flowing through electrical circuits all around you to supply the energy to keep HVAC systems working. Because electricity can be deadly, you should treat it with respect and put safety first at all times.